Welcome back, Algebra 2. We are in our last and final lesson of the year, lesson 129. We're going to talk a little bit about data and how we can display data and evaluate data. So here I have a list of the weights of 50 students in a gym class, or gym classes from all across the country. And one of the ways that we can organize the data for something like this is to use what's called a stem and leaf plot. So we have a stem and then we have a leaf. All right, and the stem here, this is your tens place. So this actually represents 80, 90, 10, 11, 12, or I'm sorry, 80, 90, 100, 110, 120, 130, 140, 150. And these represents the ones place, and all of this data has been organized into this stem and leaf plot. So basically the way it works is you would look for the lowest tens place that we have, and we can see that that's 88 right here. That's our lowest number. So we would write an 8 for 80 and then an 8 for the ones place. And then we would look for the next 80 value, and I have an 89 here and an 89 here. So I'd write the 9 and a 9. I wouldn't have to write 88, 89 again, just the ones value. So when I get to the 90s, then I'm going to start looking for the 90s values. I have a 92, I have a 99, I have a 98, I have another 92, and you just keep going until you find all of the values that fall into that tens category. So for the hundreds, I've got this one, this one, this one, this one. And I'm just looking for a 100 through 109, right? So I'm not looking for all the numbers, just 100 through 109. And when I get all of the 100 through 109 down, then I look for my 100 tens place. And I identify those, just looking for the 100s and tens. And once I have all of those identified and written in place in the right column or in the right row, then I move on to the 120s, right? Identify those. I write in the ones place for each of those. And once I have that, then I look for the 130s. I write in the ones place for all of the 130s that I see. And I might even go back and put them, oh, I missed a 120, so I'd put that in. I might even go back and put them in numeric order, which there's another 120 I missed, and so then I'd go and I'd add that in. Then I would look for my 150s or 140s. I have two 140s and I have two 150s. And so once I get all of my ones in, then I can evaluate the numbers. And it's really quick for me to do certain things, like when I want to find the range, I need to find the highest number. So this is the range. The highest number minus the lowest number. The highest number is 153 because I have these organized from lowest to highest in each row. So the highest number is 153 and the lowest number is 88. And that was so much faster than trying to look through all the numbers and figure out which one is which, right? So then I want to find my mode. So what I'm going to do is I'm going to look for the number that's used the most in the ones column. So I have 2 here, 3, another 3, 2, oh, I have a 4, a set of 4. 132 is used 1, 2, 3, 4 times. So my mode is 132. All right, so now I'm going to be looking for my mean. My mean is just going to be the 25th and 26th number because I know I have 50 numbers. So the mean is the middlemost number. So when you have an even number, you take the two central numbers and you add them together and divide them by 2. And in this case, that's going to be 118 and 119. And when I add them together and divide by 2, I get 118.5. Okay. Now, I'm sorry, that's not the mean. That's the median. I get those mixed up sometimes. I'm sure you do too. The median is the middlemost number. The mean is going to be the average. And what you would do for the average is you would add up each of these values, right? 88, 89, 89. It's a little bit easier on the stem and leaf flat because really all you need to do is add these columns together and then multiply the number of ones places that you have by this tens. So I would say I have 3 in the 80s column, so that's 240, right? I have 1, 2, 3, 4 in the 90s column, so that's 360. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 100. That's going to be 1,000. You know, and so forth and so on as you go through. And then you have all of your tens added up. Now you just add up your columns of ones. So this would be 10, 11, 17, 18, 19 here, plus, and then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, that would be 27, plus, and then I'd have 17, 18, 19, 20, 21, 22, 23, 24, 25, plus 9, 10, 11, 12, 13, 14, 19, 20, 21, plus 7, 12, 14, plus, I mean, you just see how it goes. You'd add all these up. I would have 7 and 7 is 14, 19, plus, then once you get to the lower numbers, you can start adding them together all at once. So I have 10, so I have, let's see, 5, 10, 15, and that's actually another thing you could do is you could do multiples. Just do it however you need to do it in order to add all of the ones up. So let me see if I can do it that way. 5, 5, and 5. That's what that was. So let's do it like that. Let me see if I can do it like this. So all of the zeros, I'm just going to knock them out. We don't need those. They don't have any value whatsoever. I'm just going to count the ones. 1, 2, 3. So we have 3 ones. All right. And let's do the twos. Let's count by twos. All right. 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's good. So plus 18. Let's do threes. 3, 6, 9. Okay, so that's plus 9. Let's do the fours. So I've got 1, 2, 3, 4 fours. That's 16. Let's do 5. So 5, 10, 15, 20, 25, 30. Plus 30. And then I'll do sixes. That's 6. That's 12. So plus 12. I'm running into my numbers, so I'm coming down here. I'm going to do sevens. So I've got 1, 2, 3, 4, 5 sevens. So that's going to be 35. Plus, I'm going to do the eights. 1, 2, 3, 4, 5, 6, 7, 8. 7 times 8 is 56. Plus, I have 1, 2, 3, 4, 5, 6 nines. 6 times 9 is, oh goodness, 6 times 9 is 54. So then I would add all those up, and that would give me 233. I would keep multiplying here. So let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 of these. 1, 2, 3, 4, 5, 6, 7, 8 of these. If this is 9, 10, 11, 12, it's 12 of these. And then I have, all right, 2 times 140 is going to be 280. 2 times 150 is going to be 300. If I have 12 of these, that times 130, so 10 times that would be 1300. And then 2 more 130s would be 260, so 1560. That's going to be 80. That's going to be 800 plus 160. That's going to be 960. And that's going to be 990. Okay, so then I would bring my ones that I added all up. It's going to be 233. I would add all those numbers up, and then I would divide it by 50, because that's the number of values that we have in this chart. When I divide it up on my calculator, I get 118.46. How about that? That's very close to the median. Very, very close. But you can see it's a lot easier to calculate all those numbers doing it like that than it is by doing it. The stem and leaf plot makes it a whole lot faster. And then if you count it like I did the second time in multiples of the same number, then it makes it a lot easier to calculate as well. And so we found our range, mode, median, and mean fairly quickly. Now another way to display that type of data is in what's called a histogram. And histogram is where we take the numbers, it's like we take the stem and leaf plot and we turn it on its side. And then we count the number of values in each one. And we see which one has the most. And it tells us the distribution of weights. And we see we have more people in the 130s bracket than we do in any other. That tells us a lot of information. We have a lot of people in the 100s, and we have a lot of people in the 130s. Okay. So that's some good information to have. You can tailor your shirt sizes. You could tailor like the equipment that you buy. All of that would be good information to have for a gym class. Now, as we go further into data organization, you'll discover or come across what's known as the normal curve. And in the normal curve, that's where we would take this histogram of information and we would plot it on the number line. You'll find that the normal curve, once you get enough data, the mean, the median, and the mode all end up being the same number. We've already seen that when we did the median and the mean here. This could easily round up and be 118.5, but the mode just isn't there yet. Over time, it would end up being the same number. So either we would have this number would go down and these numbers would go up, and they would eventually meet somehow, and they would be the same. All three of these would be the same. That's maybe that's why they all start with the letter M. I don't know. What I do know is that that is what is represented by the normal curve. And when your data fits the normal curve, it means you've gotten enough data to support whatever study it is that you're doing. Now, we can apply something called the standard deviation to our data. And the standard deviation is a group of measurements that are normally distributed. It's useful because 68.2%, let me show you this chart here, 68.2%, that would be this middle group is where all 68.2% of all the measures in your data group are going to lie in the middle. And that's going to be evenly divided around the mean of your data. And then you're going to have another standard deviation that is on the outside of each one of those, where 13.6%, where you'll end up having a total, if you go within two standard deviations of each other, 95.4%. If you add up all these percents, you get 95.4%. That is where the majority of your data is going to lie, with the majority of it in the center around the mean or the average. And the mean and the median and the mode are all going to be the same number lined up. All right, so what is a standard deviation? How do we get there? What does that mean? All right, a standard deviation, we're just going to use a small sample of numbers here because it's easier to find it when you just have a few rather than all of those other numbers that we had. So we're going to do this in just a small sample. So it won't be as accurate, but it'll be closer. It'll give you an illustration of what we mean. All right, so first we find the average, or the mean. The mean is the average of these four numbers. These are the numbers in our set of data right here. See, that's where sets come from. So we find the mean. Those four numbers added together is 36 divided by 4 gives us 9. So we go to our number line and we graph our mean. And then we measure each individual number, the distance from the mean. So here I have plotted 5, 7, 10, and 14, and I've measured the distance. So I have 2, 7 is 2 away from 9, 10 is 1 away from 9, 5 is 4 away from 9, and 14 is 5 away from 9. So I'm going to take the square of the, or the square root, sorry, not the square, but the square root of the average of the squares of the distances from the mean. So 1, 2, 4, and 5, those are four numbers, four distances. So that's the number of distances, because what you do is you're going to use the average, right? The average is dividing by 4, right? Because you have four numbers. So that is the number that you have, the distances there. 1/4 of this is going to give you the average of the squares of the distances, and then you take the square root of that. So when we square each of these, we add them together. We get 46 times 1/4, or 46 over 4. And we can take the square root of 4, that's 2. And then the square root of 46, that's 2 times 23. We can't really take anything else out of that. So we just go on our calculator and we plug in 46. And I'll show you, let me pull out my calculator here. We plug in 46, the square root of, and then we divide that by 2, and we get 3.3911. The number drops off here. These are our significant values. So we say approximately equal to 3.39. And that's our standard deviation. So then what we do is we take that standard deviation over to our chart, and we start at the median, which is 9, and we measure 3.39 to the right, and we indicate that 34.1% of our number is going to land here. And then we go to the left of our mean, and that's another 34.1% for a total of 68.2%. So that's one standard deviation away from the mean on either side. So then we do that one more time. We get 3.39 away from this standard deviation to here, and that's going to give us 13.6 more, and then we do that again on this side. And if I were to actually write the numbers here, what I would do, I would say, all right, this 9 is my mean, and then 12.39 is one standard deviation away. And I'm going to use my calculator to do the rest of this because I can't do it all in my head. Plus 3.39, that's going to be 15.78. So this is 15.78. All right, from this previous one. And then I'm going to find my other standard deviations by subtracting. All right, come on, calculator. So I'm going to say 9 minus 3.39, and that's 5.61. So 5.61 is one standard deviation to the left or below, and I'm going to subtract another 3.39, and that's going to give me 2.22. And that's the range from 2.22 to 15.78, where the majority of my data should fall given that set of information. And that's how you would find your standard deviation, and how you would set up your graph for standard deviation, and how you would calculate the different categories. So within here, I would have 68.2% of my data, as you can see. All right, so if we go back and look at our data, 5.61 and 12 point, so we had 5, 7, and 10. 7 and 10 fall within here, don't they? That's half of our data. The other two are really close. So you can see how that kind of plays out with the standard deviation. It does ring true. And that's all we have for our final lesson of the year. I hope you found this interesting. There are no example problems. We just had a little bit of a lecture for a change. And I will see you all at the final. Hope you do well. The final is online. And I'm excited to see what everyone does. And I guess I'll see you in lesson 1 of Algebra 3, or what we call Saxon Advanced Mathematics.